Hello everyone, today I will share you a hot equipment in the industry. That's industrial vision camera or bigger machine vision system. Okay, this outline of sharing. The first one, what are machine vision system? The second, components of machine vision system. The third one, type of machine vision systems. The first one, the function performed by machine vision system. And the fifth one, applications of machine vision system. Okay, now we come to the part one. The machine vision system are generated by integrated components include the vision camera and sensor, a computer hardware, and software algorithms that offer operational guidance by processing and analyzing the image captured from their workspace. And the data acquired from vision system are used to control and automate a process or inspect a product or material. Then, what are components of machine vision system? The machine vision system are typically include of 5 key components. These components are common and may be seen in another system. Firstly, the key component, of course, the vision camera or the sensor. A vision camera mission is capturing the image of product, that's material for its processor and software to analyze is it a defect or good. The second thing is very important is lighting. The camera cannot capture a high quality image without lighting. It's not a simple just eliminate for products. For each of distinct feature on product, we need to set up a different position and light technique. The third one is lens. The lens collects light scatter of an object and reconstruct an image of that project on the camera sensor. The fourth thing is processing units and visual display. This can be a computer with a software that developed from the camera manufacturer to show and set up tools for detection. So we can see every product through and result of detection good or bad. Some brands also have special HMI for their camera. So we can link directly from that HMI to the camera and see the image or product and fall on that HMI. And the fifth one, communication system include the camera controller here. Please take note that some camera model or brand will not have the controller. And the next one of the communication system is PUC. And next one, rejection mechanism. Okay, now we come to detail for each component. The image sensor inside the machine vision camera converts the light captured by the lens into a digital image. It typically uses CCD or CMOS technology to translate the photon into electrical signals. The output of image sensors is a digital image composed of pixels that show the presence of the light in the areas that the lens had observed. And resolution and sensitivity are critical specifications of the image sensors. The first one, resolution. That's the number of pixels produced by sensor in the digital image. The sensor with a higher resolution produce a higher quality image. It means more detail can be observed in the object being inspected, and more accurate measurement can be obtained. The next one, sensitivity. That's the minimum amount of light required to detect an output change in the image. And the resolution and sensitivity are inversely related to each other. An increased resolution will decrease the sensitivity. Next one about lighting. Lighting is responsible for illuminating the objects and highlighting its distinct feature to be viewed by the camera. It's the one critical component of machine vision system. The camera cannot inspect objects that it cannot see. Lighting parameters such as distance of the light source from the camera and object, angle, intensity, brightness, shape, size, and color of the lighting must be optimized to highlight the feature being inspected. And the lighting source can supply by this type of the lighting. It can be directional or diffusive. Lighting techniques in machine vision system are classified as 6 techniques as below here. Okay, I will come to detail for each technique. The first one, bright field and dark field. One of key components of machine vision imaging. It determines what kind of lighting is optimal for your setup to achieve the best light-dark contrast. Bright field lighting or dark field lighting. Firstly, I will talk about the bright field. This method for imaging reflected light. Light comes from the source is reflected into the camera. So that's small defect or edge, which typically scatter light and not picked up by the camera. This creates a bright image, but area with engravings, scratches, or indentations may not be as well defined. To get a good set of bright field lighting, you want the light source to be an angle to subject or imaging surface at 45 and or 90 degrees. Typically, position this light source closer to the object or surface is advantage, as this helps cover a larger surface area and can help eliminate some of the issue seen with the image reflective surface or edge. And about the dark field, different with the bright field. Dark field lighting only captures scattered light. By capturing only the scattered light, edge and surface defect become more highlight in the image because they are the thing that best scatter light. To best set up a light source for dark field. An ideal angle of light around 10 to 15 degrees. This angle allows for edge, defects, rise, etc. to scatter the light well, while not having the surface of the target reflect too much light back to the camera. Okay, we come to the backlighting. Backlighting illuminates the target from behind. It creates the contrast as dark appear against a bright background. Backlighting used to detect the holes, the gaps, cracks, purples, and scratches on clear or transparent parts. It's suitable for measuring, placing, and positioning parts should you monochrome light. Okay, next we come to dumb, flat, and axial diffuse. Firstly, about the dumb diffuse. Dumb diffuse lies very effective on specular, curve, and topography surface. And the axial lies effective for specular, flat, and angle surface of varying height. And both techniques have very specific application criteria that can present a challenge under some lighting case. We also can combine dumb and axial diffuse together for better illumination. And flat diffuse lights are often referred to as flat dumb because of the similar performance characteristics we share with the classic dumb illuminator. It's sufficiently oversized compared with the object of interest. Flat diffuse light can provide an effect at a larger range of working distance than dumb. Reflected light provide non-directional, soft illumination that is free of shadowing. This effect is well suited for inspecting highly specular and curved objects, but at close working distance. Then we come to the next component of the machine vision system. That's the lens. The lens captures the image and relays to the image sensor inside the camera in the form of light. Most lenses are equipped with the color recognition capability. The lens of machine vision camera can be an interchangeable lens, type C mount or CH mount, or a fixed lens. Lenses are characterized by flowing properties, which degrade the image quality then they can capture. The first one, the field of view, is referred how much area the image sensor views. Lenses with a high focal length have reduced field of view. The next one is about the depth of field. Refer to ability to maintain the acceptable image quality without the refocusing if the object is moved farther from the plane of best focus. It also influences the object's range of acceptable motion. And the next one, aperture. That's the opening of the lens through which light passes to the enter of the camera. It controls amount of light entering the lens. Here you can see this is a bigger aperture and this is smaller, and it's inversely related to the depth of field. Here and the next component is processing unit and visual display. The first one about the vision processing unit or the machine vision system. It uses algorithms to analyze the digital image produced by the sensor. The vision processing involves a series of steps performed externally by a computer or internally for standalone machine vision system. First, the digital image is extracted from image sensor and it's relayed to the computer. Next, the digital image is prepared for analysis by making the necessary features on the image stand out. The image then analyzed to locate the specific feature need to be observed and measured. Once observations and measurements of the feature are completed, they are compared to the defined and pre-programmed specifications and criteria. Finally, the decision is made, and the results are communicated. Then about visual displays. For each vision camera brand, we will have a software to visualize the capture image and result of the inspection. That software we can do on the thing to set up the vision camera, such as set the reference image, define the right locations of objects or products, add the tool into inspect, or setting up for PLC communication. And the next one about the communication between vision camera and PLC. And nowadays, almost vision camera have the Ethernet communication protocol and also the gate. So we can connect directly to the PLC. If I need more station for SMI or PC, we can use a hub or switch. If the camera doesn't have an Ethernet connector, it can connect to PLC via I/O. And for rejection mechanism, it belongs to PLC side. PLC take inspection result from camera and will have generate a command for rejection mechanism. It can be a cylinder to kick out defective product. Next one, I will talk about the type of machine vision system. The first one, that's the light scan camera. A light scan camera captures digital image one light at a time. It can inspect multiple objects in a single light. They are ideal in a high-speed conveying system and continuous processes. They are suitable in a continuous web of material such as paper, metal, title, large pack or cylinders. The second type is area scan camera. It's your rectangular shaped image sensor used to capture the image in a single frame. The area scan camera can perform almost all common industrial tasks and easier to set up and align. Different with light scan cameras, it prefers inspect stationary object. And the third one is 3D scan camera. 3D scan camera can perform inspection as X, Y, and Z planes and calculate the object position and orientation in space. They utilize the single or multiple cameras and displacement sensor. In a single camera setup, the camera must be moved to generate a height map that results from displacement of the laser, location on the object, the height of the object, and its surface planarity can be calculated using a calibrated offset laser. In a multi-camera setup, laser triangulation is deployed to generate a digitized model of the object, shape, and location. 3D scan cameras are ideal for inspecting 3D form bags and robotic guidance applications. This type of machine vision camera can tolerate the slight environment disruptions, for example light contrast and color variation, while providing the precise information. They are widely used in the metrology, factory automation, and defect analysis of the parts. Next one, I will talk about the function performed by machine vision system. The first one, presence inspection. Presence inspection is the process of confirming the quantity and presence or absence of the parts. It's one of basic operations performed by machine vision system, and the most widely performed task in the most industries. Practical applications of presence inspection include the counting of the countable product, for example portal, cruise, and checking the presence of the label on the food packaging, electronic components on PCBs, adhesive applications, and crew washer in the fasten part. The second function is practical positioning. Positioning is the process of the comparing the locations and orientations of the part to a specific spatial tolerance. The location and orientations of the part in 3D or 2D space are communicated to a robot or a machine element for it to align or place the target in its proper position or orientation. Machine vision positioning system offer more accuracy and speed than the manual inspection, alignment, and positioning. Practical positioning applications include the robotic pick and place part on and off the conveyor belt. Positioning of glass substrates, checking of barcode and label alignment, checking of IC placement in PCB, and arrangement of the part packing in the pallet. The third function is identification. The machine vision identify, scan, and read the barcode, 2D code, direct part mark, and character print on the part, label, or package. These markings contain product name, manufacturer, day cost, lot number, expiry date, identify useful in improve the traceability of the part, inventory control, and verification system of product. Identification is accomplished by either an optical character recognition, or we can call OCR, or an optical character verification OCV system. In OCR system, the machine vision read the printed alphanumeric character on the target without prior knowledge of the character to look for. And in the OCV system, the machine vision verify the presence of the character string. The next function is flaw detection. Flaw detection is one of the most fundamental quality control tasks in the manufacturing industries, and the most utilized function of machine vision system. In flaw detection, the machine vision search for defects such as crashes, blemishes, gaps, contaminants, discolorations, and other present on the part surface, which can affect the product functional and reliability. And the presence of these defects is monitored. The machine vision system can categorize the defect by type, color, texture, and size, and sort out the defects paths for fail the criteria. And the next one about the function detecting through measurement. Measurement is a checking of dimensional accuracy and geometric tolerance of the parts. The machine vision system calculates the distance between two or more points and the location of the target fixture or the object to determine whether the measure is within the specifications. The lighting and optical system of the machine vision system must be optimized in order to obtain the highly accuracy and repeatable measurement. Okay, that's the function performed by machine vision system. In the next one, I will list down some application of the machine vision system. For the food and beverage, we can have the counting function. Counting number of the bottle in the carton box. The second is inspecting of the gap welding, open or fully closed. It helps to ensure the quality of the powder inside. And the third one is measuring the foam density on surface of the liquid. Can be coffee, soft drink, or gas soft drink. The fourth one is inspecting different color in material. For example, coffee bean, soya bean. Yeah. For pharmacy industries, vision camera can detect the defect runs, drug circuits, such as broken, missing, or mixed color. For semiconductor industries, vision camera can inspect the damaged IC, batch welding, burning on the board, on the PCBA and PCB. For mechanism industry, camera can detect the crashes, deformation for remedies.